Hello and welcome. In this video I'm gonna show you how we can use implicit differentiation for finding the derivative of a very interesting function. If y equals x over 1 plus x over 1 plus x over 1 plus x over 1 plus x over and forever, find dy over dx. When we look at this function, we can see that it's a very unusual function. We have fraction and fraction and fraction, and we have infinite fraction on top of each other. So basically, forget quotient rule for finding derivative of this function. But how we can find dy over dx if we want to find the derivative of this function without quotient rule, because quotient rule is not helpful here. We have to think for a different way. Let me rewrite this function again here. Y equals x over 1 plus x over 1 plus x over 1 plus, if you notice to here, what do you see here? If you compare this with the given function, compare this and focus on this. Do not look at any other thing. And compare it with this expression. Can you see any difference between them? Here we have x over 1 plus x over 1 plus x over forever, and we have same thing here. But what is this? This is y. Okay, if this is y, why not replace all of this with y? Because the name of all of this expression, all of this is y, and we have exactly same thing here. So we can write this in this form: y equals x over 1 plus, again don't forget, look at this, this is exactly y. So y equals x over 1 plus y. And now look at this, we have a simple relation, but this is implicit relation because x and y are mixed together, and so we can use implicit differentiation for finding dy over dx. But before starting finding the derivative of this relation here with implicit differentiation, it's better to simplify it before differentiating. Let me rewrite this expression here, this relation here: y equals x over 1 plus y. Let's multiply both sides by this to get rid of the fraction. If we multiply both sides by 1 plus y, or in another word, if we do a cross multiplication like this, we have y times by 1 plus y equals x. And if you multiply y into the bracket, we have y plus y to the 2 equals x. Of course, this we prefer to work with this expression instead of this expression. Here we have a fraction here. We have to use quotient rule for this part. But here we don't have any fraction. That's the reason that we do a little simplification and then we start differentiating. Now we want to find the derivative of this implicit relation that here we have. We do implicit differentiation differentiation for finding derivative. If you remember, when we do implicit differentiation, derivative of y is like derivative of x. Derivative of x is 1, derivative of y is also 1. But because we take derivative of y, which is the function, we have to multiply it by y prime. So derivative of y is y prime. Derivative of y to the 2, like x to the 2, is 2x, and here is 2y. But don't forget to multiply by y prime. And derivative of x is 1. Now, we factor y prime in the left. We have 1 plus 2y equals 1. And then y prime equals 1 over 2y plus 1. Or dy over dx is 1 over 2y plus 1. So, here, instead of finding derivative immediately when we look at the function, we try to convert the function, the given function, to a simpler function, or we try to write it in a different form, as we did here. We converted this explicit relation to an implicit relation, and then we used implicit differentiation for finding the derivative of the function. I hope you liked this video, and see you in the next videos.